called really best first search algorithm plus registrar's shortest path. Greedy best first search algorithm is based on only heuristic value, h of x star. Registrar's shortest path algorithm is based on only the actual cost between the two nodes, g of n value. So when you combine both greedy best first search algorithm as well as Dijikstar's shortest path algorithm, you will get A star algorithm. Any doubt in A star algorithm? Similar to greedy best first search algorithm, the only thing is in terms of evaluation function it differs. Greedy best first search algorithm is purely based on heuristic value. Dijikstar's algorithm is purely based on g of n value. But A star algorithm is based on both heuristic value as well as g of n value, actual cost. Okay. The disadvantages of A star algorithm, heuristic accuracy, there is this calculating the heuristic value is some serious task. Then memory usage, it takes more memory to keep all the nodes. Then time complexity also, these are the disadvantages. To overcome this memory usage or to overcome this disadvantage, we can use another one algorithm. The algorithm is simplified memory bound A star. A star algorithm occupies more memory. Okay? So to overcome this advantage, we can use another one algorithm, simplified memory bound A star algorithm. So the difference between A star and simplified memory bound algorithm is in terms of memory. That is, the memory is limited or bounded memory. If you set the memory limit as 3 means it can able to store only 3 nodes in the priority queue. Okay? Or if you set the memory limit as 5 means the priority queue can store only 5 nodes kind of thing. Understand? But in A star algorithm, it can able to process n number of nodes. Any number of nodes can be stored in the priority queue. So here the memory limit is only the constraint. So these are the advantages. Memory utilization uses less memory, less allocated memory only be utilized. So it avoids repeated state, it provides completeness as well as it provides optimal solution. Okay, now we are going to discuss about the algorithm for this simplified memory bound A star algorithm. write a start node, you need to mention the value of g of n, h of n as well as f of n. So what is g of n value for start node? For start node there is no g of n value, so you can take it as 0. So g of n value is 0. H of n value for start node 3. So put 3 here. And what is f of n? When you add these two values, you will get f of n. So f of n is 3. Okay. Now you can explore the start node. How many children having for this node? Yes. How many adjacent nodes? 3 nodes, A, B, C. But here we cannot explore all the 3 nodes simultaneously. Why? What is the reason? Because the memory limit is only 3. So we can store only 3 nodes in the priority queue. So first explore the 2 nodes, A and B. Later you can explore node C. So first explore node A and node B. And when you explore node A and B, you need to write the g of n value, h of n value as well as f of n value. So for node A, g of n value is 4. This 4 value. Then h of n value is 0. Then f value is 4 plus 0 is 5. So like that for node B, 4 plus 4. For node D also write the values of g of n, h of n. G of n is 3, h of n is 2, f value is 5. Okay. Okay, now we need to explore C also, but there is no memory. So enna pannalam? You can remove any one of the node, then you can include node C. So to decide which nodes to remove, you can check the f value for both the nodes. Okay, now you compare f value for both the nodes. This is having less f value. Sorry, this is having more f value. B. Node B is having more f value. So this node can be removed. Then you can include node C. And while removing this node can be considered as a forgotten node. And the f value of this forgotten node can be stored in the parent of this node. Parent of B is yes. So in this parent node, you can store the f value of this node. Okay. Next step, you can start this. So write the x node as it is. And we are going to keep A as it is. And B node is going to be removed and considered as a forgotten node. So write it in the dotted line. And we are going to include node C. Okay, for node B, this value is write the value as it is 3 to 5. Here, this is forgotten node. The forgotten node f value is updated in the parent. So this is forgotten node f value. And for node C also, you have to calculate g value. G value for node C is 5. Then for h value for node C, 1. Any doubt? Why this 4? Because after exploring all the children of this parent node, we have to update the F value of parent by taking the lowest F value of its children. S is having only 2 children currently, A and C. So when you compare A and C, 4 is minimum F value. This minimum F value is updated. Okay, after that, what is the next step? Now priority queue is having S, A and C. So in the context. Next, to process the next node, again we have to remove any one of the node, right? To find the solution, again we have to remove any one of the node. Okay, which node you can remove? A or C? Why it is C? Because C is F value is higher. So you can remove C, then you can explore the node A. A is having only one child G, so you can add G here. Okay, so here in this case, C also going to be considered as a forgotten node, and forgotten node's F value needs to be stored in the parent. But in a forgotten node, C or F value A which is having less value. For node A, F value is 6. Node B, F value is 5. So when you compare these two, which is having less value? B. So the next step is we are going to remove node A. Then you are going to add node B. What's the reason? Because F value of node A is greater than node B. But our aim is we need to get minimum F value. We need to choose the node which is having minimum F value. But here A is having more value than B. So you can remove node A. Then you can include node B. So when you remove node A remove பண்ணனா first என்ன பண்ணுவோம்? Node G remove பண்ணலாம். Node G remove பண்ணால node A remove பண்ணலாம். Next you can include these two forgotten rows. இந்த ரெண்டையுமே remove பண்ணலாம். Okay. The next step is we are going to remove node G as well as node A. This is also considered as a forgotten row, and this node F value is going to be updated here. So this 5 becomes 6 now. Because this A node is considered as a forgotten row, the F value of this node is updated to its parent. So this becomes 6. And you can include at this point, you can include both node B as well as node C. Okay, now compare the F value of both node B and node C, which is having less value. B is having less value, so you can keep node B and you can remove node C. Okay. Then this is considered as a forgotten node, and you can explore node B. Node B is having only one children, that is node G, so you can add node G. So node G, for this point listen, here after exploring is you have to update this value also, right? So in the minimum value, you take, you compare node B and C, minimum F value is 5, so this value also updated. Then when you include G, again write G of n value and H of n value. G of n value is from S to B3, B to G2. So when you add these two values, 5, right? So 5 is G of n value. Then H of n value. H value for node G, 0. So when you add these two, 5. Okay. Okay, now after exploring node B, you have to update the F value of node B. So in the children node F value is 5 தான் இருக்கு. இங்க 5 தான். So same 5. Then in the F value when you use greedy vegetables towards algorithm, what is the solution for this graph? S2 A varum. We have minimum fixed value is A only. Then A and G. So S2 A. Then when you use A star algorithm, this is for greedy vegetables search. Then for A star can it will take both heuristic value and G of n value. So when you for this part F value is 0 plus 4. In the past F value 3 plus 2 5. Here 5 plus 1 6. So when you compare these three values, minimum values this part. So it will choose A. So S2 A multiple A2 G. So both greedy vegetable search algorithm and the A star algorithm provide the same solution. But what is the solution for simplified memory bound A star algorithm? S2 B B2 G. So which algorithm provides the optimal solution? Optimal solution is optimal. When you consider the actual cost, this comes 4 plus 2 6, right? But in here 3 plus 2 5 now. So which is optimal? Okay. So the thing is, we cannot guarantee that the algorithm will provide optimal solution for all the cases, all the graphs. Optimal solution का बहुत guarantee है. Okay. Then one more thing is in memory simplified memory bound A star algorithm. If you set the memory limit as 2 means what will happen? In this case, if you set the memory limit as 2 now, is it possible to process? Set the memory limit as 2. Whether it will give solution or not? No, right? Because here the solution must take the path maximum limit that is from one node S to B solution. There are 3 solutions: S to A, then A to G or S to B, B to G, or S to C, C to G. So all the 3 possibilities have minimum 3 nodes in it. Minimum 3 nodes. So if you set the memory limit as 3 means, then only you will get the solution. Or if you set the memory limit as 5 means, you can get the solution. But if you set the memory limit as 2 means, it cannot reach our goal stage. It will stop up to this. It may stop up. We cannot process the more level.